All right, number 1, convert the angle to a decimal in degrees. Round the answer to 2 decimal places. 52 degrees, 35 minutes, 35 seconds. So we want to convert that to a decimal in degrees. The whole number part here, that's going to be the whole number part of your decimal in degrees. So it's going to be 52 degrees plus. Now we need to convert 35 minutes over to degrees. So that's 35 times 1 over 60, because 1 minute is equal to 1/60th of a degree, plus 35 seconds. We need to convert that over to degrees. 1 second is 1/3600th of a degree. So I'm going to use my calculator. 35 divided by 60.583 repeating. 0.58. I'm just going to carry the 3 out a couple places. Now convert the seconds over. So 35 divided by 3600. And that is 0.00972 repeating. 0.00972. And I'm going to carry it out a couple places. Alright, so we need to take and add those 3 together. So I'm just going to take what I have here in the calculator and add 0.58333 plus 52. Alright, and if we round this to 2 decimal places, that would be rounding this to this position here. Look at the next number. It's a 3, so it doesn't round up. So 52.59 degrees. Number 2, 61.08 degrees, and the directions say convert the angle to DMS form. So we want to change this over to degrees, minutes, seconds form. Round the answer to the nearest second. So the whole number part here, the 61, that's going to be our degree part. Now we need to take the decimal part and change that over to minutes and seconds. The way we do that is we say plus 0.08 degrees times 60 minutes, because 1 degree is 60 minutes. So 0.08 times 60, 4.8. So 61 degrees plus 4.8 minutes. So we want to take the whole number part, and that's going to be our minutes. The decimal part here, the 0.8 minutes, we're going to change that over to seconds. So I say plus 0.8 minutes times 60 seconds, because there's 60 seconds in 1 minute. So 0.8 times 60 is 48. So 61 degrees plus 4 minutes plus 48 seconds. And so once you have, if this would have been a decimal, you would just round to the nearest whole number second. There's no decimal there. So now that we're done, you can drop all the plus signs. It's 61 degrees, 4 minutes, 48 seconds. Alright, problem number 3 says, if S denotes the length of an arc of a circle of radius r subtended by a central angle theta, find the missing quantity. So we're going to have to use the formula S arc length equals r times theta. Theta must be in radians. Alright, we're given r equals 9.2 inches. Theta equals 45 degrees. What is S equal to? Alright, so we need a radius and an angle measure. We have a radius, 9.2 inches, an angle measure of 45 degrees. We need to change that over to radians. So the way that you change degrees to radians is you multiply by pi over 180 and reduce. So 45 pi over 180 reduces to pi over 4. 45 degrees is the same thing as pi over 4 radians. Alright, so let's solve for S. S is going to equal 9.2 inches times pi over 4 radian. So the arc length is going to be, we can get an approximation. That's what the directions call for. So let's see. When you plug pi into the calculator, if you don't have a pi button, I suggest 3.14159. That way you carried it out a couple extra places. This calculator has a pi button, the Windows calculator does. So 9.2 times pi divided by 4. Alright, and if we round that to 1 decimal place, that's the way these answers are given. Then, let's see, 1 decimal place is right here. So 7.2. So the arc length is approximately 7.2 inches. Number 4. Convert the angle in degrees to radians. Express the answer as a multiple of pi. 60 degrees. So to convert that to radians, you multiply by pi over 180. That's 60 pi over 180. Reduce that. You get pi over 3. Number 5. Convert the angle in radians to degrees. So 12 pi over 3. To convert from radians to degrees, you don't multiply by pi over 180, you multiply by the reciprocal of that, 180 over pi. Pi's cancel out. So now, I could simplify by crossing out. That's going to be 60. So 12 times 60. That's going to be 720 degrees. Same directions for number 6. Convert the angle measure in radians to degrees. Nine pi over 10. So again, multiply by pi over 180. I'm sorry, 180 over pi. Multiply by 180 over pi. Pi's cancel out. looks like you can cancel out between the 10 and the 180. This is going to leave you with 9 times 18, 162 degrees. Number 7. If capital A denotes the area of the sector of a circle of radius r formed by a central angle theta, find the missing quantity. If necessary, round the answer to 2 decimal places. So our formula for area is area of the sector of a circle equals 1/2 times r squared times theta. Theta must be in radians. For arc length and for area, when using those formulas, theta must be in radians. Alright, so the radius equals 5 inches. Angle measure equals pi over 6. What is A equal to? So for this problem, area equals 1/2 times 5 squared times pi over 6. Alright, so that's going to be, if you square 5, you get 25. 25 times 1 is 25, so that's 25 pi over 2 times 1 times 6 is 12. So I'll punch that in my calculator. 25 times pi divided by 12. And I get 6.54498, so on and so forth, round to 2 places, so 6.54. Since this is area, that's inches squared, or square inches. Number 8. I'm given this figure here, where the angle measure is pi over 3. The radius is 12 yards, and we want to find the area. So to find the area, this is like a sector of a circle. Definitely not to scale the way I drew it, but it's a sector of a circle. So area equals 1/2 times the radius squared, so times 12 squared, times the angle measure. So 12 squared is 144. So this is 144 pi over 2 times 3 is 6. The directions say to round to 3 decimal places. So 144 times pi divided by 6. So to 3 decimal places, this is going to be 75 point. Alright, there's the third decimal place. Look after it's a 2. So 75.398. That was yards, so this will be square yards, or yard square. For the next 3 problems, 9, 10, and 11, it says t is a real number and point P is the point on the unit circle that corresponds to t. Find the exact value of the indicated trig function of t. So we're given a point Now, these problems are just like the very first problems that we worked whenever we were defining the trig function. So all these points are on the unit circle. So if you find the radius, then the radius would be equal to 1. Alright? But we're told in the directions that the point's on the unit circle. So sine of t, remember sine is usually y over r, but in this case we just use y. So that's going to be equal to the square root of 11 over 6. And we're done. The y coordinate right there is the square root of 11 over 6. Alright, number 10, we're given the point square root of 7 over 4 and 3/4. Find the secant of t. Well, secant is r divided by y, or in this case, since we're on the unit circle, I'm sorry, not divided by y, divided by x. Secant of t is 1 divided by x, and so that's going to be 1 divided by square root of 7 over 4. So flip and multiply, and that will be 4 over the square root of 7. We don't want to leave our answer like this, so multiply the top and bottom by the square root of 7 to rationalize the denominator, and we get 4 times the square root of 7 over 7. That's your final answer. Number 11, the point is 1/3 and negative 2 square roots of 2 over 3. Alright, so to find the cosecant of t, that's 1 divided by y. So that's 1 over negative 2 square roots of 2 over 3. Flip and multiply, that'll give me negative 3 over 2 square roots of 2. Multiply the top and bottom by the square root of 2. You get negative 3 square roots of 2 over, now, the square root of 2 times the square root of 2 is 2. Then you say that times the 2 in the front, that gives you the 4. So you have negative 3 square roots of 2 over 4. Number 12 says a point on the terminal side of an angle theta is given. So this point is not on the unit circle. Find the exact value of the indicated trig function. We want to find the tangent of theta if this is a point on the terminal side of the angle measure. We would usually need x, y, and r since it's not on the unit circle. And to do that, you use the formula x squared plus y squared equals r squared. But since we want to find tangent, tangent doesn't need r, so we don't have to find r on this problem. Tangent is just y divided by x. So that's 4 divided by 5. Number 13, find the secant of 45 degrees. Alright, so we need to remember that we associate the point 45 degrees with the point, or we need to remember that we associate the angle measure 45 degrees with the point square root of 2 over 2, square root of 2 over 2. Secant is equal to 1 divided by y, or 1 divided by x. Which one is it? X, because it's the reciprocal of cosine. That's right. So I guess it really doesn't matter on this problem, but it does matter in the long run. So secant is 1 divided by x. So the secant of 45 degrees is equal to 1 divided by square root of 2 over 2. Flip and multiply, and you get 2 over the square root of 2. Then rationalize, you get 2 square roots of 2 all over 2. And these 2's here cancel out. Make sure you cancel those out and don't leave those there. So the secant of 45 degrees is equal to the square root of 2. Alright, number 14. Cotangent of pi over 3. So we need to remember to associate the point 1/2 square root of 3 over 2 with pi over 3. That's pi over 3, or 60 degrees. So we associate that with the point 1/2 square root of 3 over 2. Then we remember cotangent is equal to x divided by y. 1/2 divided by square root of 3 over 2. Flip and multiply. That's going to give us 1 over the square root of 3. Rationalize. So you get the square root of 3 over 3. Number 15, the cotangent of 570 degrees. 570 degrees is bigger than 360 degrees. So we need to subtract 360 degrees from that as many times as we need to get it between 0 and 360. So that's the cotangent of 210 degrees. Alright, so we need to figure out the reference angle for 210 degrees, and we need to figure out if the cotangent of 210 degrees is going to be positive or negative. Alright, so first let's figure out if the answer is going to be positive or negative. Using the Salty C chart, 210 degrees is between 180 degrees and 270 degrees. So that angle measure is in the third quadrant. In the third quadrant, tangent and its reciprocal cotangent are positive. So when I evaluate cotangent of 310 degrees, I'm going to get a positive answer. Now I need to figure out what the reference angle is so that I can write down the point that I need to use. So the reference angle chart, in the first quadrant we have the reference angle, theta. In the second quadrant we have 180 degrees minus theta. In the third quadrant, that's 180 degrees plus theta. In the fourth quadrant, it's 360 degrees minus theta. So we're in the third quadrant, so we want to use the formula 180 degrees plus theta. So we say 180 degrees plus theta equals 210 degrees. We solve for theta, and this will give us our reference angle. So we get theta equals 30 degrees. 30 degrees, or pi over 6. And we associate that with the point square root of 3 over 2, 1/2. So now, we want the cotangent of this angle measure. So, cotangent is equal to x divided by y. So the cotangent of 570 degrees is equal to x divided by y is equal to, we said the answer is going to be positive. And then it's square root of 3 over 2 divided by 1/2. flip and multiply, you get square root of 3. All right, number 16. The sine of 135 degrees minus the sine of 270 degrees. Alright, so the sine of 135 degrees, the way that I find that, the same way that I just found the cotangent of an angle measure of 570, I use the two charts first, the Salty Sea chart, to tell me the positive or negative sign. So where is it located? 135 degrees. This is 90 degrees. This is 180 degrees. So it is located in the second quadrant. So when I take the sine, that's going to be positive. Now to figure out the reference angle for 135 degrees, use the reference angle chart. And the formula for the second quadrant is 180 degrees minus theta. Alright, so that's going to be, so I'll say 180 degrees minus theta equals 135 degrees. This is going to give me the reference angle for 135 degrees. Subtract 180 from both sides. So I get negative theta equals, that's going to be negative 45 degrees. Now divide both sides by negative 1. Theta is equal to positive 45 degrees. We associate 45 degrees with the point square root of 2 over 2, square root of 2 over 2. And then sine, we said it's going to be positive, and it's the y-coordinate. So the sine of 135 degrees is square root of 2 over 2. Alright, so this one up here, square root of 2 over 2, minus the sine of 270 degrees. 270 degrees is down here. It's a quadrantal angle. So if you remember your unit circle, this point down here, that's 0 on the x, negative 1 on the y. Sine is the y-coordinate. So it's negative 1. So this is square root of 2 over 2 minus, and the sine of 270 degrees is negative 1. Now I'm going to have to simplify that. I'm going to do that right here. So I have the square root of 2 over 2 plus 1. If I look on my answer sheet, I don't see that. So you need the answers that are written down there are 1 fraction. So I need to make these two terms 1 fraction. So the common denominator between square root of 2 over 2 and 1 is a 2. And then 2 goes into 2 one time. 1 times square root of 2 is square root of 2. Plus 1 goes into 2 two times. 2 times 1 is 2. So my final answer is square root of 2 plus 2 all over 2. Number 17. Secant of theta is less than 0. Tangent of theta is less than 0. Name the quadrant in which the angle theta lies. Alright, easiest way to do that, write down your Salty Sea chart. And remember, this means all trig functions are positive in the first quadrant, Sine and its reciprocal cosecant are positive in the second quadrant. Everything else is negative. Tangent and its reciprocal cotangent are positive in the third quadrant. Everything else is negative. And in the fourth quadrant, cosine and its reciprocal secant are positive. Everything else is negative. So secant of theta is less than 0. So that means secant's negative. So secant is negative in these two quadrants. Tangent is less than 0. So tangent's negative. Tangent's negative in these two quadrants. So the place where that overlaps is the second quadrant. So that's where this angle measure is. Second quadrant. Or quadrant 2. Alright, number 18. We're given that the sine of theta equals the square root of 7 over 4. The cosine of theta equals 3 over 4. Find the secant of theta. The fastest way to find the secant of theta is to remember that secant of theta is 1 divided by cosine of theta. So it's the reciprocal. Secant is the reciprocal of cosine. So you see the answer for cosine? Take the reciprocal. That's the answer for secant. So 4/3. And we're done. Number 19. Cosecant of theta is equal to negative 9 over 8. Theta is in quadrant 3. Find cotangent of theta. Alright, so it tells us we're in quadrant 3. So we're down here. When we find the cotangent, is the answer going to be positive or negative? Positive, because we're in the third quadrant and cotangent is positive down there. Now keep in mind that in the third quadrant, the x values are negative and the y values are negative. So if we have to solve for y or for x to get to work this out, then we have to make sure we make them negative. Alright, so let's see what information we have. We're given cosecant of theta is negative 9 over 8. Cosecant is also r over y. Okay. So what is the radius? It's not going to be negative 9 because the radius can't be negative. So the radius is 9. So r equals 9. The y is what we put the negative with. So the y is going to be negative 8. Remember we said the y's had to be negative in the third quadrant. And to find cotangent of theta, we say x over y. So we need to find x. We have y is negative 8. We need to find x. The way we do that is by using the formula x squared plus y squared equals r squared. So plug in what we know and solve for what we don't know. Plug in 9 for your radius, plug in negative 8 for your y, and solve for x. So we're going to have x squared plus negative 8 squared equals 9 squared. So that's x squared plus 64 equals 81. Subtract 64 from both sides, and we get x squared is equal to 17. Now take the square root of both sides. Now usually in math, if we take the square root of both sides and we're solving for x squared, then we put a plus or minus in front. Well, we said we're in the third quadrant, so the x values have to be negative. So it's just x equals negative square root of 17. Now that we have x, we can solve for the cotangent theta, for this x over y. So it's going to be negative square root of 17 over negative 8, which will be positive square root of 17 over 8. And the last problem, number 20. Use the even-odd properties to find the exact value of the expression. Do not use a calculator. So the cotangent of negative 60 degrees, using the even-odd properties, that's equal to the negative cotangent of 60 degrees with 1/2 square root of 3 over 2. Cotangent is equal to x over y, so that's 1/2, and bring the negative, so that's going to be negative 1/2 over square root of 3 over 2. Flip and multiply, we have negative 1/2 times 2 over the square root of 3. The 2's cancel out. That's negative 1 over the square root of 3. And then rationalize, we get negative square root of 3 over 3.